If Earth is spinning at over 1,600 kilometers per hour, how does anything launch from it and still escape into space? The answer is not brute force. It is physics. Because rockets do not escape Earth by simply going straight up. They escape by turning Earth's spin, gravity, and sideways speed into a path that does not fall back down. Think about it. Before a rocket even leaves the launch pad, it is already moving. The ground, the air around it, the rocket, the fuel, and everything inside are rotating together with Earth. So when the engines ignite, the rocket is not starting from zero. It is already riding a moving planet. That is why many rockets launch eastward. Near the equator, Earth's rotation gives a spacecraft an eastward speed boost of over 1,600 kilometers per hour. But that free push is only a small part of the story. To reach orbit, a spacecraft needs far more speed. For low Earth orbit, the target is roughly 28,000 kilometers per hour, and this is where the real physics begins. Going up is not enough. A rocket can fly straight up, cross the edge of space, and still fall back down. That is not orbit. That is just a very high jump. Orbit happens when the spacecraft moves sideways so fast that as gravity pulls it down, Earth curves away beneath it. It is falling, but it keeps missing the ground. That is why rockets go sideways. At the beginning, a rocket rises almost vertically because the lower atmosphere is thick. If it tried to go sideways immediately, it would waste energy fighting dense air and create dangerous stress on the vehicle. So first, it climbs. Then, as the air thins, the rocket gradually tilts. This curved path is part of what engineers call a gravity turn. The rocket slowly turns from vertical flight into horizontal flight, using careful guidance and gravity to shape the path. By the time it reaches orbital altitude, the goal is no longer just height. The real goal is velocity. That is why a rocket's path curves instead of shooting straight like an arrow. It is not trying to escape Earth's spin. It is trying to build enough horizontal speed to become an object in orbit. Now, here is the deeper part. Gravity does not suddenly disappear in space. Astronauts are not floating because there is no gravity. They float because the spacecraft, the astronauts, and everything inside are falling around Earth together. Even the International Space Station is still under Earth's gravity. But because it is moving sideways at about 17,500 miles per hour, it keeps falling around the planet instead of falling into it. That is orbit, not floating, not escaping gravity, a continuous fall around a curved Earth. To leave Earth completely, a spacecraft needs even more energy. Escape speed from near Earth is about 11.2 kilometers per second. But rockets usually do not do that in one simple straight shot. They use stages. They burn fuel. They drop dead weight. Some missions enter orbit first, then fire again to head toward the Moon, Mars, or beyond. This is why rockets are mostly fuel. They are not just lifting a spacecraft. They are lifting the fuel needed to lift more fuel while fighting gravity, drag, and time. So when people ask, how does a rocket escape a spinning Earth? The answer is, the spin is not the enemy. The spin is part of the launch. Earth gives the rocket a small sideways head start. The rocket engines add massive thrust, gravity bends the path, and horizontal speed turns falling into orbit. So rockets go sideways because space is not the real achievement. Orbit is. Height gets you above the atmosphere. Speed keeps you from coming back. And if you add even more speed, you can finally leave Earth behind. So next time you see a rocket curve across the sky, remember, it is not losing control. It is not being dragged by Earth's spin. It is doing exactly what physics demands. It is going sideways fast enough for Earth to keep curving away beneath it. Now tell me this in the comments. If orbit is really falling around Earth, should we call spacecraft flying or falling forever? Follow for more space science explained without the confusion.